Hey everybody, welcome back. And today we will continue talking about the chemical equations. But I will start with some examples of equation balancing for practice, how to balance equation. Example, sodium plus Cl2 plus chlorine gives sodium chloride. The reactants are sodium and the chlorine, and the product is sodium chloride. How to balance this equation? How to balance? So the first step, to write the reactants. Okay, and to see how many of each atoms in the reactant. So in the reactant we have sodium and chlorine. So how many sodium atoms we have? We have one. How many chlorine atoms? Remember, we have two. While in the product, let's make it clearer so you can see. In the products, we have also sodium and chloride. Sodium and chlorine. How many sodium atoms? It's one. How many chlorine atoms? It's one. So now sodium is balanced as sodium. It enters one and it exits as one. Chlorine is not balanced, so it enters two but exits as one. So we need to convert these two into one. How we can do that? By writing half here. So now chlorine half Cl2 is only 1 Cl. So now we have 1 Cl. And now Cl is balanced too. Another equation is H2 plus Cl2 produce HCl. Okay, so we have to write the reactant and the product. So the reactants and the products. We have in the reactant hydrogen, 2 hydrogen. And we have hydrogen in the product too, but only 1 hydrogen. And in the reactant, we have Cl, we have 2 Cl. And in the product, we have Cl2, but we have only 1 Cl. So as you can see, both hydrogen and the chlorine are not balanced in the reactants and the product. So hydrogen entered 2 and exit 1, and the chlorine entered 2 and exit 1 atom. So we have to convert these 2's into 1's or these 1's into 2's. So how can we do that? Simply, you can write half and half. This is one way. Or you can just write here 2. When the number is outside the molecule, so it is multiplied with every atom. It is multiplied by the number of each atom in the compound. So this molecule is HCl. When we write the number 2 outside, so it's 2 hydrogen and 2 chlorine. So now have 2 hydrogens and we have 2 chlorines, and now the equation is balanced now. Here I prepared some equations so you can try to balance them. Some of them are easy and the other are complicated. So you can try them to see what you can do and how you can balance them. And at the end, write the balanced equation in the comments down below. The ionic equation. The ionic equation is an equation that produces the ions. So I need to find out find out what are the ions that entered or produced from the reaction. Okay. So first we have to know these symbols. S means solid. L liquid. G gas. Sometimes you find it as V vapor. It's a gas state. 2 aqueous solution is the aqueous. So usually the ions came from the aqueous solutions. Remember that note. Okay. So this is the decomposition of sodium chloride in water into its ions. So we add sodium chloride solid into water. And the products are sodium ion aqueous, which means dissolved in water. Aqueous means dissolved in water. And the chlorine ion, chloride ion aqueous, which are dissolved in water. Okay? So the Ionic equation can show us that the decomposition of a compound in water or melting of a compound producing its ions. Or it is a reaction between ions to form a new compound, chemical reaction. Okay, and an example is sodium hydroxide aqueous with sulfuric acid aqueous that produce sodium sulfate and water liquid. How can we get or predict the ionic equation? So every aqueous compound means dissolved in water, and once it is dissolved in water, it will dissociate into its original ions. So you will turn every aqueous compound into its ions. Okay, let's see this equation. Okay, sodium hydroxide, 2 sodium, don't forget the numbers, 2 sodium hydroxide and hydrogen fluoride, so, and the sulfuric acid, sorry. So this 2 goes to sodium and hydroxide. So the ions of this aqueous compound is 2 Na positive plus 2 OH hydroxide ion negative 1, and both are aqueous. What else in the reactant? There is sulfuric acid, H2. When the number comes below the atom, so this number is specific for this atom. While if it comes outside, so it's general, so it will be multiplied by every atom. So this H2O, H2SO4. H2SO4 is composed of hydrogen proton, the proton, hydrogen ion, and I used 2 because they are 2, plus one SO4, one sulfate ion. And this sulfate ion is -2. And we have to write equals to. Okay, these are the reactant. Then this reactant will give us water is liquid, so we'll not get the ions from the liquid. We get it only from aqueous. Na2SO4 aqueous, so we will decompose them into their ions. So 2 Na aqueous plus 1 SO4 aqueous. So when we write the equation and then H2O2, H2O. H2O, we will not decompose it into protons and oxygen ion. No, because it's liquid. So we write it the same. So after writing the ions of the reactants of the aqueous or molten reactant and products, I will see the similars. So we have in the products 2 sodium and 2 sodium equals in the product and the reactant, they will go together. They will be crossed together. So we don't have hydroxide ion here, we don't have hydrogen here, but we have sulfate, so it will go with this, will cross it out with the sulfate in the product. And at the end, we'll write the remaining. So the remaining is 2OH negative plus 2H positive give 2H2O. And this is the final ionic equation. So finally, we have 2 hydroxide ions with two protons give us 2 hydrogen, 2 water molecules. Okay, and this is the ionic equation. So how to get the ionic equation? We dissociate the aqueous and molten compounds into their ions in the products and in the reaction. Any other thing will not be dissociated, will remain the same. And then we cross out all the similarities between the reactants and the products, and we write the remaining from the products and from the reactants, and that would be the ionic equation. So this is the explanation how we do the ionic equation, so decision of ionic compound in water. And this is what we did now. We wrote any aqueous into their ions, and the water remains the same. And when we put them out, we write the remaining as the ionic equation. So we need to express all these equations into their ionic equations. I will do one more for you. And I hope you tried the others and write down the final ionic equation for me in the comments down below. This is the sodium chloride equals, and the silver nitrate equals to, remember that we uh, dissociate the aqueous or molten, okay? When the ionic compound is dissolved in water, become aqueous solution, or melted, they will dissociate into their ions, their original ions. Sodium nitrate and AgCl, silver chloride as precipitate. So first, we take the aqueous compounds and write their original ions. So NCl will be sodium ion and chlorine ion. Then AgNO3 will be silver ion and nitrate ion. These are the reactants, the product. So sodium nitrate will give sodium ion and nitrate ion. And for the AgCl, it's a solid, so you will not get its ions. You write it as solid because this is solid precipitate. Okay, after that we will cross out the similarities. So here we have sodium in the reactant and sodium in the product, so they will go together. We have nitrate and nitrate. We will cross out together. And we have to write the remaining. The remaining is the Ag positive, aqueous, and the Cl negative, aqueous, in as reactants, and they will give silver chloride as a precipitate. So what happened in this reaction? In this reaction, the silver ions from the silver nitrate come and react with the chloride ion from sodium chloride and form the AgCl precipitate. And this is the Ionic equation. So next video will be about the moon. It's very important too. Uh, don't forget to make the homework, the equations, to get the ionic equation from the equation that I gave you today and the balancing of the equation. Don't forget to balance any equation before estimating its ionic equation. Okay? Anyway, that's all for today. Thank you for watching and see you.